All right, solving quadratics. We're going to look at probably the best method that will always work, that will get us through every single quadratic we want to solve today. Quadratic formula. Now, we're going to be first showing how to find the discriminant, which I just want to highlight is just a piece of the quadratic formula. So by finding the discriminant, we'll be able to determine how many and what kind of roots, again, roots, solutions, x-intercepts, they're synonymous. We're going to determine what kind we're going to have, and then the quadratic formula answers should back up what we predicted should happen. So let's get right into it. First problem, 3x squared plus 5x equals 2. Now right off the bat I have a problem. I need this equal to 0 because the original quadratic formula is x equals, so I need to solve for x, meaning we need to get it equal to 0. So subtract the 2. 3x squared plus 5x minus 2 equals 0. All right, let's find our discriminant. Discriminant uses a b, a, and a c value. So first and foremost, let's identify those values. These are all taken from the standard form of a quadratic, which is ax squared plus bx plus c. So the coefficient for the squared term is my a, coefficient for the linear term is my b, and the constant is my c. So hopefully looking at this, you can come up with three values pretty quickly. A is going to be 3, b is 5, c negative 2. Plug and chug, baby. If the discriminant is b squared, that means I'm going to start finding my discriminant by doing 5 squared minus 4 times a value, which is 3, c value, which is negative 2. All right, let's simplify. 5 squared, 25. Now, careful, let's do all the multiplication first. Order of operations, that's a negative 4 times 3 times negative 2. A negative 4 times 3 times negative 2. Now first off, I'm just identifying, I'm multiplying three things. 2 of them are negative, which means I'll end up with a positive. Now negative 4 times 3 is negative 12, times negative 2 is a positive 24. So my discriminant value is 49. Now I didn't have enough room, but all of you should have that chart that we copied down. Now there were 4 actual categories. If it's positive in a perfect square, we had 2 real rational roots. Look at what we have. Positive number, and it is a perfect square. Meaning, we should come up with 2 real rational roots. All right, let's hope that we're right. Here we go. Reminder, this just helps us identify what type and how many roots. It is not the solution. It's not. So now we have to go through quadratic formula to find the solution. Now, let's be intelligently lazy. I'll show you what I mean here. X equals negative b value plus or minus the square root of b squared minus 4ac. No! It's the discriminant, right? You already found it. I can't tell you how many of you start plugging and chugging again. You just did that, right? So just put in 49. Oh, life just got so much easier. All over 2 times a value. All right. Simplify time. We get a negative 5 plus or minus 7 all over 6. Now, notice something here. The plus or minus means we have 2 different scenarios. In one scenario where we add, and one scenario where we subtract. Negative 5 and 7, they can combine, so I want to run my 2 scenarios. So I take negative 5 plus 7 and divide by 6, and I take negative 5 minus 7 and divide by 6. So I arrive at my final answer. X equals, I'll get 2 over 6, which is 1/3. I'll get negative 12 over 6, which is negative 2. And those are my solutions / roots / x-intercepts. That's using discriminant to determine how many and what type of roots, and then quadratic formula to find my actual roots. Okay? Now, we're going to look at another one. Same process, but it takes on a little different form. All right, let's take a look. 2x squared plus 10x plus 11 equals 0. This one's nice. It's set up for us. I don't have to move things around. I can go right into my ABC value. A is 2, B is 10, C is 11. All right, let's use the discriminant. B squared minus 4 times A times C. 10 squared, 100. Now, negative 4 times 2 is negative 8. Times 11, negative 88. My discriminant here is 12. Now, again, hopefully you have the chart out. It'll help you diagnose. That's not my answer. That tells me how many and what type of roots I'm going to have. This tells me, okay, it's positive and a non-perfect square. I will have 2 real irrational roots. Can you see that okay? Oh, it's off camera. Roots. Here we go. Now, I'm going to use the exact same process. I don't have to do the full quadratic formula because I found what goes in the square root. So let's just plug it in. Negative b value plus or minus the square root of 12 all over 2 times my a value. Now this next step, there's a little bit of simplifying that has to happen. Yes, 2 times 2 will be 4 on the bottom. Cool. Negative 10 doesn't change. But square root 12, you need to break down a radical. You've been doing this for a while, shouldn't be too tough. We'll do a little sideways tree so we can see it. What goes into 12? 6 and 2. What goes into 6? 2 and 3. We have a pair of deuces. So the 2 comes on the outside. Only the lonely stays inside 3. One more thing. What do they all have in common on the outside? Remember, outsides with outsides, insides with insides. All my outsides are divisible by 2. So I can break it down and it becomes negative 5 plus or minus square root 3 all over 2. Now let's point out some differences here. When we got to this step in our first problem, I noticed and I mentioned those can combine, so I run my 2 scenarios and break them apart. Look here though. Can negative 5 combine with the square root 3? No. They're not allowed to add. So if I asked you what's negative 5 plus square root of 3, the answer? Negative 5 plus square root 3. You can't combine those. So because we can't combine them, we're allowed to leave it as one singular answer. And so this represents 2 roots, plus or minus. That represents 2 roots. This is exactly what we get. That's your exact answer. If I were to ask you for an approximate answer, approximate is a synonym for rounding. So if I were to ask you to approximate, you would have to plug this into a calculator, round to the nearest, whatever I tell you, and then run your 2 scenarios, okay? Quick tutorial on how to use discriminant to determine what kind and how many solutions / roots / x-intercepts, and then how to use the quadratic formula to solve to find those roots / x-intercepts / solutions. Hopefully it helped.